Hey guys, how's it going? And welcome back. This is dbcrypto, and today I'm joined by Kenta Iwasaki, who is co-founder and CTO of the Perlin project, and also Darren, who is head of communications and compliance. So firstly, of course, thank you both for taking the time out of your week to come and speak with me today. This is actually the first time that we as a community have had you guys come on video, so it's really exciting to have you on.
Yeah,
that's
definitely.
terrific. Thanks for the time to talk to us.
Awesome. So Perlin's a project that is primarily looking to leverage the extremely underutilized computational power that we've all got on our phones and our tablets, laptops, computers, etc., and allow us to put that power to work for great causes like scientific research, like big data, machine learning, those sorts of use cases. So as I understand it, there's really quite a strong motivator for the conception of Perlin, looking at that power waste, hearing Dorji talk, relating that to the Bitcoin network, etc., and of course many other assets as well. So it goes without saying that this is a really hot space. I've seen many other projects building in this area, for my research particularly as well. So it's really good to be able to unpack some of those unique points of Perlin today. So I'd like to start with you, Kenta. You've got a background as an engineer, and also you've done some work in artificial intelligence as well. From the reading that I've done, there's really quite a common sort of recurring pain point with those that are doing that really computationally intensive work with cost and availability and those sorts of things. So could you give us a bit of a high-level overview of what Perlin is, but also talk to us about your motivation for joining the project?
Definitely. I mean, the whole compute being expensive in the marketplace today definitely is the one sort of reason as to why I wanted to do Perlin with my CEO Dorji in the first place. But if we take a step back, so Perlin, well, I like to keep project descriptions nice and concise. Perlin itself, it's a ledger, but it's a ledger that really tries to solve a lot of the big problems that we've been seeing over in the blockchain space. And that the reason why we decided to create this ledger is, well, initially we wanted to work on a decentralized cloud solution, mainly just figuring a way on how we can really tap into this underutilized computing space to then be able to solve a whole nother problem with the fact that we're running out of compute resources in the real world today. Transistors can only get so small. Moore's law is kind of coming into a halt. And as that's progressing on, we're just having higher demands for compute as we're coming into much more interesting new kinds of techniques on creating much more accurate, more informative models in deep learning, in AI, computational physics, geometry, all those kinds of fields in which computational power is an absolute necessity. Because we're unable to support that cause, we need a new way to garner supply. And the fact that we have all of these devices so abundant over even in developing countries, that's really where we can be tapping this next generation of supply and to cater for all of these big enterprises and startups. So, but in building a decentralized cloud, like building a decentralized application almost, you have to go and take your pick into choosing a ledger. Because without a ledger, you can't really have a decentralized app. You need a place to store all the data, something to maintain, jurisdict all the state that's going on into building up this entire ledger. And we've looked at Bitcoin, we've looked at Ethereum, then you've got all these second layer scaling solutions, you've got all of these other kinds of solutions that's just coming up. Bitcoin's been out for about a decade now. Is it really? It's just kind of disappointing what's out there right now, if you kind of get what I mean. Like all these kind of drawbacks out there, like what's going on? We've had our world today is running on distributed systems. We've got Google, we've got Facebook, Microsoft. They've been doing it for decades, way beyond Bitcoin. The initial Bitcoin paper proposed a very interesting proposition to come up with this decentralized ledger to have an open permissionless network. But the next step forward, there's only been these little tweaks, little additions that just have been kind of lackluster. So that's where Perlin's second next step. Actually, that's one of the really big technical motivations for me to get into this space. I was initially an AI researcher for Naver, and I'd go by the book. I'd read a lot of papers. I'd implement them on a day-to-day basis, and I'd make new papers, new ideas from all kinds of different fields. So apart from just AI, I did signal processing. a lot on natural language processing, statistics, and whatnot. I then made my way into commercializing it. So I started to get heavier into the software engineering, how distributed computing really works. Fundamentally, what Bitcoin is really solving, it's really to do with this whole nice trade-offs between consistency, availability, and partition fault tolerance. Won't go too much into that, but Bitcoin basically proposed a very nice solution onto the distributed system space on how we manage state. And now looking at the blockchain, it proposed a very interesting sort of alternative solution to it. Perlin's our take on a whole new way on how we can view these family solutions and into, well, what sort of perspired into us creating a whole new ledger. So that really is what Perlin is today, and it really is sort of my motivation as well.
Beautiful, thank you. Now, you already sort of got into it a little bit, but you've chosen to go down the path of a DAG-based ledger. So for the viewers, could you perhaps sort of firstly just sort of explain what that is, what a DAG-based ledger is, as opposed to more popular and well-known alternatives that we're used to, but perhaps more importantly, why you've chosen to go down that path in your design? What's beneficial about that for you?
Definitely. I mean, I think there's a very big misconception on what exactly, these DAG-based, these consensus-based, these proof of work, proof of stake. There's this very weird sort of mix-up, and I think a lot of this terminology is being misconceptualized quite a bit. To put it out there, Bitcoin, if you wanted to put it very specifically, is a DAG-based ledger. Actually, I just want to take a step back and say what exactly is a ledger. I mean, a ledger, it's just comprised of two components. The first component is a consensus protocol. The second component, if you choose to make this ledger be open, be usable by the masses, like Bitcoin, it's used by the masses, you need a Sybil deterrence or resistance mechanism. The consensus protocol of Bitcoin is the longest chain rule. And, people hear about it, but that's actually the whole reason why we have a consensus mechanism. The point of a consensus mechanism is that if you've got a bunch of people connected to each other over the internet, and there's inevitable lag with our devices communicating with each other, the consensus protocol is trying to, in spite of having a chaotic network, a network where everyone's out of sync with each other because of message delays, we're trying to still get a consensus out of the network so that everybody can still regard each other's messages in a way so that they're always in sync. We're trying to make people sync together. That's the point of a consensus protocol. Sybil resistance mechanism, when we talk about Bitcoin, that's what we talk about proof of work and proof of stake. So proof of work, proof of stake, those are the means in which we can justify who has power over the network. So, in a capitalistic society or an economy, money, in essence, is what we consider the Sybil deterrence or resistance mechanism. It's what we obligate on as to who has rights, who has control over the system. And there's many different sorts of new kinds of resistance mechanisms coming out back and forth over here. So really, the longest chain rule, it's about, given a directed acyclic graph of blocks, of forks, different sort of diverging paths, what you pick is the longest chain out of the graph. So that's why what I'm arguing is that, you can consider Bitcoin or consider Ethereum a DAG-based ledger. Now, what we're doing on the other hand, we're supposedly using a DAG-based ledger. We're doing a very interesting sort of variant or a bootstrapped version of Avalanche, which is another directed acyclic graph consensus variant. We're deriving new kinds of heuristics, or the proposition of Avalanche is, if we look at that graph of conflicting forks again, could we derive new relationships, new heuristics or scores, quantitative scores, numbers that could actually let us yield consensus out of a chaotic, unsynchronized network, much more securely, safer, and most importantly, faster. So that really is just what a DAG-based ledger, I'd say, really comprises of. The consensus protocol is how we interpret this DAG.
Now, like you said, you're building it on an improved variant of Avalanche. Now, we can research Avalanche. We can see that it's fast. You have low latency, high throughput. It's a robust protocol. So I guess what I want to ask is, what were some of the shortcomings that you wanted to change with Wavelet, which is sort of your improved variant of that?
Definitely, yeah. So Avalanche definitely is very interesting on how its ideas are really great, but just so much is actually being assumed. I mean, there's this whole thing in academia where mathematicians would not really know how to express their ideas in AI, for example. So they cover up their misunderstandings by putting more math onto the paper. Much like Avalanche, that's the same sort of case here. Actually, the math, you'd expect it from someone taking a bachelor's in electrical engineering or maybe their master's to be able to understand that kind of math. And the math which dictates the safety, the correctness of Avalanche's as a consensus protocol, it's really lackluster. Show it to any master's student, any PhD student that does a great deal of work in probabilistic mechanisms. Avalanche models it as a Markov chain. Won't go too much into that, but there's way too many assumptions to really go to show that it's actually safe, it's correct. And another thing is that there's pseudocode in the paper of Avalanche. If you were to directly implement the code that's on that paper, you're going to have a ledger, or you're going to have a consensus protocol that is in no way ever going to scale up. The code they gave is very unoptimized, there's actually bugs in the paper. A lot of people in the community have fixed and corrected those bugs, but there's just so many different hindrances and flaws on how they describe this entire Avalanche system on paper. And there's not even proper mention of Sybil resistance mechanism, proof of work, proof of stake. What do you actually use with Avalanche? Avalanche is just a consensus protocol. So all of this kind of stuff, that's what Wavelet comes to address. There's so much. This paper is so vague that we went out of our way because we just thought the idea was so great. It just wasn't kind of put to its glory as to what the Avalanche paper showed. So one is that we completely changed how the pseudocode or the structure on how Avalanche was expected to be coded. There's a bunch of pseudocode on how Avalanche implements its ideas to ensure safety and consensus. We completely rewrote that system to make it so that the code could run way more better, much more viably. It's easier to test the code and to ensure safety and correctness of the consensus protocol on even consumer devices. We want to emphasize on making this ledger suitable, making Avalanche usable for consumer devices, because, I'll get into that a bit later. But one is performance is, in terms of performance, we've improved on that aspect. Security is another aspect. There's no talks about proof of stake, really, in the Avalanche paper. And in implementing the Avalanche paper, we came up with a few nifty little lines of code changes that actually got us to build on top of full-blown out proof of stake protocol. And it's not your ordinary proof of stake protocol here. Actually, it's really, really interesting or unique compared to any other proof of stake protocols you see out there, like any proof of stake blockchain you'd see. Typically like EOS, for example, you see that they have a fixed validator committee, 21 people. And there's a big problem with that, because if you have millions of people relying on EOS, 21 people are the ones responsible for validating the entire network. That becomes a big problem. Like, you don't want 21 people to decide the fate of millions of dollars, right? Yeah. So in Wavelet, we have a new POS that is committeeless. There is no fixed size committees anymore. Some other projects might claim like, oh, we have a rotating committee of 100, 1,000, but that still is kind of, it's inherent to security flaws. I could if I was an attacker, I could just try shut down those 200 people if I really wanted to disrupt the network. And 200 people is not a big deal to a hacker. So one is that we actually are able to bring POS closer to the security properties, diminish the margin or even rival POS with the security properties of proof of work. That's one thing that Wavelet guarantees. The second guarantee is that we've actually rewrote essentially how Avalanche works, taking inspiration of some of the great ideas that it does put on the paper, however. And what's more, we further formalized and provided a lot more stricter safety guarantees. Some people had arguments about partial synchrony, or basically on how it's not that safe as a consensus protocol, because it's just the proofs about it, or claim that it only really works on a partially synchronized network, a network where we can assume that people will eventually be synchronized, people won't ever really disconnect. That's not true. Actually, a lot of systems in the real world are partially synchronous. Yeah, but basically there's been a lot of sort of FUD, I would say, about Avalanche that doesn't really make sense, but there are a lot of things that need to be fixed with Avalanche, and that really is what Wavelet, the reason why we brought Wavelet over to the masses. We just needed a ledger to build our decentralized cloud. And it was just really sort of saddening that after all these years of development after the Bitcoin paper, there's not anything really interesting or worthwhile or a complete alternative solution available out there just yet.
So is it fair to say that you took really the foundation of Avalanche and you've just added on all these improvements to it? Excuse me. Yeah,
there's a ton more. There's even like how we distribute out validator rewards. That's a completely different topic. If you don't distribute validator rewards out fairly, validators could try turn the network over a different leaf and attack everybody. There's stuff like how can we ensure the TPS, the benchmarks of the ledger is safe and secure. I have a big thing against a lot of projects claiming that they have 100,000 transactions per second, for example.
Yeah.
Just because it doesn't make sense. Yeah, and it's surprising, you know. Okay. But yeah.
All right, so we've already gone through a little bit of the Sybil resistance. Can you talk to us, or can you just explain for the viewers, in simple terms, the concept of metastability? Because that's something that's highlighted there as well.
Oh, metastability was really just a way they framed, the Avalanche paper framed this family of consensus protocols. Really, metastability, it's a term that comes from physics, all about attempting to reason about the stability of particle states. That's not the reason why. Well, they kind of sort of made it a metaphorical reference as to why the consensus protocol work as it is. But no, I like to think of Avalanche as cold hard. It's just a consensus mechanism. It's nothing too special. It's just another way of thinking away from the longest chain rule. It really is a buzzword if I had to put it at most. The only reason why I referenced it in the blog post titles, the sort of content we had, for example, the Avalanche paper wanted to call it a metastable consensus family. Fine, I'll call it a metastable consensus family.
Okay, now we're already there. Let's talk about that TPS notion. You've done a stress test of Wavelet, and you claim that you can reach 10,000 TPS. So, talk to us about that. How have you tested that? How have you benchmarked it?
Yeah, definitely. So, I mean, being very specific, it took about 3 weeks to test it all. It was when the ledger was pretty much done. Smart contracts were already supported. Monetary transactions could be done. We did it on 240 consumer grade nodes. I'd say consumer grade because it's something like each node has specs similar to a person's laptop nowadays. 15 gigabytes of RAM, about 4 vCPUs. They each have about 60 gigabytes of storage space, and they're just distributed over Singapore, Japan, and also US Central. We got the node specifically from Google Kubernetes engine, and that's pretty much how we made our stress test. It was consistently, they just kept spamming the heck out of each other with transactions, and then we just looked at, on average, how many transactions per second they were doing. Now, I kind of like to go into why these claims we hold I want to show why it makes sense.
Yeah.
Well, first off, a lot of projects are not going to tell you in depth on how they even benchmark their ledger. A lot of guys claim theoretical results. They kind of bull about it quite a bit.
Yeah,
so every single time, I see a project that says they have 30K TPS, 50K, 100K to a million. And they claim like, oh, that's the theoretical limit that we can handle. Well, if they're running 240 supercomputers, then sure. I guess I can completely understand what you're saying. And I mean, just the logic, the reason why I'm really like sort of bullish or skeptical about it is just because, well, think about it like this. You have a transaction, it's maybe 10 kilobytes of your disk space, all right? We're claiming 10,000 transactions per second. That's about 100,000 kilobytes per second on a consumer grade PC. That's already putting quite a load on your laptop. Luckily, what we did was we made a way so that at a sacrifice of slight security, we made it so that it can prune transactions as they come by. So in our stress test, to compensate for the disk load, the disk space load, much of the transactions after a certain point gets pruned off of each node so that we can just overall test how fast the ledger is as a whole. Realistically, in the real world, we're not going to be looking at 10,000 transactions actually being done per second until some really huge decentralized applications start coming into the picture. And by then, we'd be expecting for there to be much better hardware. Well, not much better. It just needs to be moderately better than what the sort of hardware we have today. So 100,000 kilobytes, that's already stretching it. Now, when we talk about the 30K, 50K, 100K, 1 million TPS, maybe if you want your laptop to suffer or die, or you want to intentionally kill all the laptops you use for your stress test, then sure. But your laptop's just going to outright disconnect from the internet, saying that it doesn't want to get any more transactions or verify any more transactions at that point. So, it's a good thing to like just warn people out, because a lot of people are not aware. I mean, it'd be really great if we had that speed, right? It'd be a good benefit, but it just doesn't make sense in today's world.
Yeah, absolutely. It's really important. I like what you've said. That's very realistic what you're talking about. So, what do you think makes Perlin superior to current and sort of upcoming future competitors?
So because we went on the ledger aspect as well, we'd be competing against the blockchain projects. But most importantly, our real end goal, it's to solve this problem that compute's getting too expensive. We need a new way to figure out some supply fast. Really, our unique viewpoint is that we sort of put our words where our mouth is, so we actually do get the work done. We really highly encourage open sourcing a lot of the work that we do. And as a result, we have garnered a developer community. There's people from Shopify, Microsoft, all these guys that are working day by day, just trying out our libraries, and a lot of other decentralized projects that are definitely very interested in using the ledger for their own purposes, etc. On the compute notion, we've also iterated through several different kinds of verifiable computing schemes. There's the verifiable computing scheme. It's the core gamut, or the sort of gold mine, which empowers a decentralized cloud, a potential decentralized cloud competitor or market. Some people have taken to Intel SGX, so like these so-called trusted secure enclaves. The biggest problem with that is it just doesn't seem realistic to actually imagine a bunch of hardware vendors all of a sudden agreeing into letting SGX be on their manufactured hardware devices. Basically, there's almost no way that hardware is actually going to definitely adopt Intel SGX, because it's just ridiculed the problems. And Intel SGX is just one trusted secure enclave. There's several others out there, some by Qualcomm, some by a lot of huge hardware vendors. There's no way they're going to let SGX be the only one out there.
Yeah.
Because of that fierce competition. you can't really be expecting adoption for realistic secure enclaves until maybe 2050, 60. I don't know, when the compute market somehow dies. For example, and everyone reaches a consensus. All right, yeah, let's just make one enclave. We take a more general approach. We're using game incentives, game theory-based incentives instead, where we've got a compute supplier, we've got a compute customer. They both have their own goals. We call this the mini-max game. The reason why it's mini-max, well, the customer's trying to minimize how much money they want to give to a supplier. The supplier wants to maximize their profit. They both hate each other, basically. And that's the game theoretic sense. Now you have a ledger. That's the beauty of a decentralized system. There's the ledger. You can think of it as a jury. The jury is able to dictate the game and really set out the ground rules so that both players need to try and do whatever they can so that the opponent is at a disadvantage. And with that, we can basically ensure that, hey, in the end, everyone's going to get what they want, but not completely what they want. As a result, some of the resources are going to get lost, but hey, this is a verifiable computing scheme that works in general for any kind of device. It does not assume what devices you have. And that's essentially the ground basis for how we verify compute on Perlin. There's a lot more specific details, like how do we balance incentives on both sides. We're going to be releasing a blog post, an updated white paper on that by around the end of this year. So definitely stay tuned for that. Cool. But what's going to be more interesting is that this compute layer that's going to be native to our ledger that we're releasing, Wavelet, that's going to be coming out by around the end of this month. And with that, there's a lot of exciting stuff. We're going to be showcasing demos on being able to train or deploy our machine learning models on over hundreds of devices easily. We've already built the tools realistic enough for it. And we've been experimenting with these tools with our partners over the time. One of our partners, for example, NITI.io, it's the innovation arm for the Indian government. They're very interested in privacy preserving deep learning, being able to protect their customers' data. And, with them, we've ran quite a number of experiments already on how we can ensure the integrity of the computation so that people don't lose money in being able to use a decentralized cloud computing market in a secure manner.
You're appealing to the masses in the sense that you want, your everyday person to be able to contribute their power to this decentralized computing aspect or idea. How easily is someone who knows nothing about this stuff going to be able to contribute their computing power?
Right. So we care a lot about user experience in that case too. It really is just download, run an app. Oh, Android support's going to be by around the end of this year. I mean, we've got the whole technical roadmap over on our website. It really is just run an app, leave it and forget it, and just come to realize that it's actually making you money overnight. That's how easy it is.
Yeah, cool. Now, that's some really good tech talk that we've just gone through over the past 20 minutes. Maybe you can jump in here, Darren. I wanted to talk a bit more about some business and community development. So, as we've discussed, it's a super competitive space in decentralized compute. So as far as, community development and things like that, we've sort of just touched on it, but, is that a priority for you at the moment, or are you just focusing more on the tech?
Look, business development and community development is always a priority in any project. If I attack those one at a time. So on the BD side, for supply, we already have a very, very significant amount of cloud power ready to deploy. At around or nearly 380 petaflops, we're already the biggest distributed grid computer in the world. So with the vast amounts of compute already available on devices as well as that, the source of supply is just staggering. And I think, as Kenta touched on, the game theory stuff, with the generous economic rewards that we've built into the platform, I think supply is never really going to be a problem. You're going to have communities in impoverished developing nations who are going to jump at the chance to earn dollars while they sleep on the devices. And eventually we'll probably even be reselling cloud compute to centralized providers. On the demand side, which I think is the more interesting, so we already have nearly 200 strategic and private token holders. So many of those have their own portfolio companies, accelerators, incubators, whatnot, and all of them with very significant sort of demand for cloud. And that alone will be sufficient to sort of bootstrap the platform in the early days. On top of that, we've already got 60 or more cloud partners also signed up who have substantial cloud demand. So they'll be coming online, and more will be coming online as we grow. So with the kind of discounts as well that we'll be offering on existing cloud services, I think up to 80% in some cases, we're pretty confident demand's never going to be an issue either. And I mean, Kenta's touched on it, but it's estimated to be a $180 billion market today, and estimated to be around $300 billion by 2021. So there's more than enough on the table and up for grabs. More on the community side, I mean, we're obviously committed to building community. The community is the lifeblood of any project. And we're a very tech-driven project with a focus there is really on the devs who recognize Perlin's tech is a real deal, and also ahead of the competition in all our verticals. So Kenta's run through sort of the specifics of that, but the simple message is we're ahead. We're doing things which no other team's done. And we want to build that developer community to sort of help us refine it and to build on top of it. What Kenta and the dev team have already achieved in such a short time is incredible. But we know that we need our community also to help take our tech to the next level, through adoption and through testing. So, I mean, just on that, Kenta's talked about Nidi.io in India. So we've partnered with the Indian government and with Telkom, which is Indonesia's largest telecommunications company, has about 180 million users, to launch a global AI hackathon. We're going to be engaging with more devs around the world to sort of, we're challenging to come up with ideas on how to use AI and distributed computing and sort of some of Perlin's technology to actually help benefit real communities, social and economic inclusion, that kind of stuff, which is really exciting because it's real world sort of applications. And it's also a really incredible opportunity for those devs in the community out there to work with Perlin, with really strong teams in India and Indonesia and around the world to create real and lasting sort of positive change for needy communities around the world, and to actually build out real use cases and applications. If you're talking about Indonesia and India alone, the two countries we're focusing on that hackathon, that's about 1.6 billion people, which is, I think, around 20% of all the human beings on Earth. So the kind of potential for exposure for the people that join us in our community and that sort of engage with the hackathon is absolutely spectacular. The website will be going up soon. You'll be able to click there from the Perlin website. It's going to be launched. It hasn't actually been officially announced. It will be later today. And ultimately, look, I think it's also a really prime opportunity to Perlin to engage with potentially thousands of AI, machine learning, and other tech companies around the world who are all going to be sort of potential providers and customers for the cloud platform. So that was a long answer to the question.
No, it's okay. I was just going to say, we'll stay tuned for that update. That sounds really interesting, the hackathon stuff. And it's great that you've got that, really quite significant BD already done, with your strategic partners and on the demand side, like you mentioned. So, yeah, that's fantastic. We're just sort of running out of time here, so I'm pretty keen to just wrap things up here. But just touching on the Perl token quickly, you've had a successful seed strategic private sale, excuse me, and you have additional sales sort of to be announced. Do you have any other updates or details on that?
Look, we obviously want to bring as many people as we can on the journey with us as we grow, more token holders, people out in the community, grassroots supporters. Right now, we're focused on developing the tech and building out the business so we can capture a slice of that, $200 billion market. But we're also working with all our existing stakeholders to figure out, how best to go ahead and to, attract the right kind of community that's going to support us long term, which is what every project sort of needs. So stay tuned for announcements on that one.
Got it, cool. All right, great. So for all information on Perlin, the website is perlin.net. I think you've got a really fantastic project that you're building here, guys. So I wish you all the best for the coming months. I know you've got a lot going on, as you've both mentioned. So again, I thank you both for coming on today.
Yeah,
Awesome,
thank
man.
you.
Thank you so much for having us.